Global trade operates on extreme efficiency, moving millions of tons across oceans in days. Yet, at the end of that journey, these massive vessels often end up sitting perfectly still in the water, waiting in line to unload. 60 kilometers inland, the situation is completely different. In Egypt's 10 of Ramadan City, a sprawling industrial corridor is constantly churning out textiles, electronics, and auto parts for the global market. The tension between these two realities comes down to simple geography. Every piece of raw material those factories consume, and every finished product they export, has to squeeze through a strictly limited number of coastal seaports. The physical boundary where land meets sea becomes an impassable bottleneck. Thousands of incoming containers and thousands of outgoing trucks are all fighting for the exact same few square miles of concrete, causing the entire system to grind to a halt. You cannot physically expand the coastline. Dredging deeper harbors or building larger coastal facilities will never solve the spatial limits of the local supply chain because the land itself runs out. When cargo sits idle at a congested port, the economic damage compounds quickly. Customs clearances drag out for days, and factories miles away stall out because they are waiting on delayed raw materials. Those delays instantly increase the baseline cost of every single item moving through the Egyptian trade network, long before it reaches a store shelf. How do you fix a port's operating efficiency when the facility itself is completely out of usable real estate? The solution is to separate the administrative processing of the cargo from the ocean entirely. This is the concept behind a dry port, an inland freight terminal that does exactly what a seaport does, but operates dozens of miles away from the coast. Instead of sitting at the dock, cargo is moved off the ship and shuttled inland for processing. The new 10th of Ramadan City Dry Port spans 189,000 square meters, built to process 100,000 containers annually, absorbing volume otherwise stuck at sea. Delivering a facility of this scale requires specialized capital. The regional engineering firm EDECS is building it, and MEDLOG, the logistics arm of the global MSC Group shipping empire, will operate it. The two companies recently executed the formal engineering, procurement, and construction, or EPC contract to get the yard built. In infrastructure development, an EPC contract award is a critical threshold. It means a project is no longer a bureaucratic proposal. Earthworks are beginning and physical delivery is actively underway. Under the 30-year public-private partnership, MEDLOG is financing and building the port. Once commercial operations begin, the Egyptian government collects a fixed $1 million annual fee, plus 10% of all cargo handling revenues. To guarantee the project actually moves forward, the Egyptian cabinet granted the site a golden license, which instantly fast-tracks all required permits and bypasses standard bureaucratic delays. This map highlights the crucial transportation link making it possible. Cargo moving to the dry port won't get stuck in highway traffic. It will travel along the Al Rubiki to Belbis dedicated freight railway, covering 63.5 kilometers straight from the coast. Once the containers arrive, the facility will rely on smart transport systems and digital integration, ensuring goods are tracked and cleared almost instantly without generating a massive paper trail. Combining a dedicated rail transit line with highly automated inland processing removes traditional truck-to-coast logistics entirely from the equation. Zooming out from the 10th of Ramadan City reveals that this facility is the first piece of a much larger national master plan. This map shows the facility as a keystone, bridging Sokhna Port on the Red Sea with Mediterranean hubs like Alexandria. The target is to scale this model nationwide, rolling out 32 separate dry ports connected by 7 logistics corridors. This network upgrades Egypt's role in global shipping. Instead of serving as a coastal transit point where ships just pass through, the country becomes a fully integrated high-speed logistics hub. For the domestic economy, rewiring the map physically shortens the supply chain for inland manufacturers, dropping their costs and speeding up their export timelines. All of this traces back to the physical work underway following the contract execution. Managing an inland yard of this size requires strict precision. The massive footprint of container stacks demands specialized operators who move volume at scale. The financial commitment from a multinational logistics arm like the MSC Group proves that Egypt's broader 32-port vision is commercially viable for private investors. With physical construction active, the project has a strict timeline to go live by early 2028. The future of global shipping isn't found in deeper harbors or bigger ships. It is found in rethinking the physical geography of trade on dry land.